Welcome back. Our next speaker is Pawel Ekk-Ciernikowski, Data Science Practice Lead at Software One. He will share insights on leveraging Azure Video Indexer and Azure Databricks to transcribe videos while integrating machine learning models for both audio and image recognition. He will demonstrate the seamless integration for enriched video transcription. The title of his talk is Video Transcription with Deep Learning Module for Recognizing Sounds. Welcome, floor is yours.
Thank you very much. Okay, welcome everybody. As has been stated, I want to introduce you to one of the POC that we have conducted for one of the biggest TV agency in the world, and which was successfully delivered by using combining of various Azure services and open source. As was mentioned, I'm currently leading the data science domain at Software One. I've been involving in the data analytics for 10 years now, and I'm also trainer and lecturer in the data science area. If you want to stay in touch, feel free to connect with me at my LinkedIn. So, what was the project goal? The main project goal was to meet the requirements of WCAG. This is the organization which assess whether the web are accessible by people with various disabilities. Of course, regarding the videos, it's mostly the hearing or vision impairing. So, how can we bring and how can we support the people with vision or hearing impairing with benefit from the videos? There is three things. The one is the video transcription. So we want to provide the transcripts of the videos about what people are saying in the videos. The second thing is the part of the background sounds, because in the videos it's sometimes that something is not visible, like barking, like explosions, like fireworks, but it should be also provided in the good transcript. And the third and the most complex thing is audio description, so providing the information of overall what is happening in the video. The part of this first POC, the first stage, was only transcription and background sound detection, and on this the two topics I will also focus today. One more thing about this project goal, about this web accessibility initiative, is that the accuracy of the transcription and background sound detection should be very high and should be higher than 99.9%. But at the beginning, a quick recap of the type of caption, the type of transcript which we can provide to the videos. There is basically three main transcription possibilities. There is subtitles, closed captions, and open captions. And we can differentiate one from each other by four main categories. This is language is consistent with audio, this ability to turn off, the recognition of background sounds, and information about the moment in which that speaker is changed. The subtitles are characteristic only by this ability to turn off. You can easily see in various streaming platforms the subtitles, and you can change the language from one to another, but there is no information about background sounds or about the information when the speaker has changed. The most fulfilled all of this characteristic is closed captions, when the language is consistent with audio. So if you have the video in English, the transcripts and the captions will be also in English. If there is in Serbian, there will be also in Serbian. You also are able to turn off the closed captions. The background sounds are being informed in the transcript, and the information when the speaker has changed is also provided. The open captions is very similar. There is only one difference. There is no ability to turn it off. You can see it, for instance, at the social media. The videos in Facebook are mostly provided with open captions. Okay, so after this short introduction, what was the technology of the POC? We mostly based on Azure. We have the video file, which can be provided from the customer system or can be provided via the dedicated application, and it's landed in the Azure Data Lake storage. Then we are starting with providing the transcription by first using the Video Indexer, the Azure service, which is dedicated for creating the transcript, but also provided a lot of more detailed information from the videos. And then we have the Databricks, in which we have the custom model for the background sounds, as Video Indexer doesn't consist all of the sounds that are required for the WCAG. The Databricks will be also used for one more thing, which I will mention in the next slides. After the Databricks enrich the transcript with the background sound, we are providing the transcripts and save it to the data lake, so it can be move on to the video and also provided on the VOD website. How does the model of the background sound detection works? So we had this transcription with timestamps from a video indexer, and then we divided the divided the audio into 4 3-second chunks. Of course, this duration of the chunk was different in case of different number of words in the specific chunks. There, these chunks are going to the model, and the model recognizes whether it contains some of the special sound, and if yes, which sound is it. For instance, in this example, the detected sound was gunshot, so the information about gunshot has been provided to the transcription with timestamp at the end of the line in which the chunk has been. How we provide this information to the model and how the model works. It is possible, in theory, to use the just raw audio signal to the machine learning model, but it have some limitations that we don't have all of the interesting and important information from the audio. So that's why we are visualize the voice, visualize the sound. In this case, we use the spectrograms to have the information about all of the frequency from the raw audio. So it's like visual representation of the voice frequency in time. If you want to use Python for it, there is a library Librosa, which from raw audio is able to provide the spectrogram. What is the example of the spectrogram? It will be on the next slide. So we have the emergency vehicle. If you can hear and see it in the picture, we have some same frequency with some changes over time, which is easily visible on these spectrograms. If we want to go a little bit further with other sounds, we can see, for instance, the glass break. If we imagine that the glass break, it's like silence. Then we have a sound on or all of the frequency, which is very loud. And then we have the silence again. It is something completely different from, for instance, wind or from rain, which in wind, we have just a very calm sound at the lower frequency with one or two frequencies which are more dominated. And if we have rain, we have the frequency which is also divided, but it's rather one frequency at a time. So there's no else like a glass break when it's like the whole frequency at one time. Of course, when we wanted to modeling something, we should also be aware of how one voice is different from another. This kind of exploratory data analysis, which we have conducted for this POC, was to cluster the sounds. So we wanted to know whether one sound is very similar or is something completely different from another. At this chart, we can see, for instance, that explosion are rather different from any other sounds. Also, glass break is rather the many points outside of the main group of points, which consist alarms, dogs, and gunshots. And for music, we can see that, yeah, it's the most difficult part because music can be very different. We have pop music, we have techno music, we have Bach, and so on. The frequencies from the similarity of the music is across the whole the cloud of points, from being very similar to alarm to being very similar to glass break. And how we can process the spectrogram with neural networks? Of course, we treat the spectrograms as the vision, so we can use the various neural networks architecture. But most commonly, we are using the convolutional neural network, which provide the information what pixel is not only on the specific place, but also what are the pixels in the neighborhood. So we are able to connect the dots and understand the whole picture. In this POC, we used both custom and predefined architecture, like being available in the Keras library. In Keras library, we have various reading neural networks, which are available at the provided website. And there is information about what are the time of learning this neural network, and also how many hidden layers are there. We are mostly experiments with the ResNet network family, and this was chosen for the final product. Okay, what is the next step to be able to have? So we have the transcription, we have some background sound detection, but we also want to improve the video indexer. Why we had to do it? Because of course, when we have the news agency, we have a lot of new words, new special words, new locations, new names, which appear in the news. Yeah, that it's some person became the president of the country and appear in the news much frequently than before. And this was one of the biggest issues to provide, because of course Video Indexer as the service hasn't the ability to just read the whole information from the internet and trying to find out the specific person. Of course, it's being improved over time, but for the news agency, it's important that if somebody is appearing, we should have it in the transcript. How did we approach it? We started with newspaper feed, so the news agency has also the newspaper, so we are able to read the articles from them and extract the keyword, which we then provide in form of the TXT file into Video Indexer to improve its accuracy on newest words. Okay, but easy to say, keywords extraction, but how to approach it? Basically, we had three ideas how to do it. The, I would say, so-called simplified approach, the statistical approach, and deep learning approach. We started with the simplified approach. We just thought that, okay, we have the English videos. So if there is some non-English word in the video or in the newspaper, we should take this non-English word, which appear more than once, because maybe it's something important. And yeah, it was correct, and it works quite well. Wasn't so hard to implement. But then we thought that, okay, we have the simplified approach. Maybe we should came up with something more complex and using some statistical approach. So we basically compute two metrics, the term frequency and term frequency inverse document frequency, which see what is the word, what are the words which are provided in the specific documents and which are not so frequent in other documents. Because it will be the keywords for the document, for the news, for the information that we just read. And okay, so we select the word with high value of this metrics and provide it as the keywords. Okay, it doesn't work, it didn't work at all. So we go with the third approach. We are thinking maybe we should use some deep learning approach and using the name entity recognition. So select the words which are marked as location or person, so it will be able to provide some more specific keywords which we were looking for. And yeah, it was the right approach which we have used. Did we buy this name entity recognition model on our own? No, we have used the Hugging Face library, which consists of various. This is open source library, which consists of various areas of the machine learning models which are ready to use, like multimodal, like computer vision, and natural language processing. And the natural language processing was the one that we have used. We have used from the natural language processing the token classification and used the name entity recognition model, which provides us for information, the location, person, organization, such as data science conference, or miscellaneous, so some important words, some special words, but outside of these three categories. One of the advantages of the Hugging Face is that we are able to test from our website the specific model and how it works for the simple data set or simple example. And as you can see in the right bottom, we provided, for instance, my name is Sarah and live in London, and Sarah was recognized as name, as a person, and London was recognized as a location. Okay, and last but not least, okay, we have it all together. We have it as we have the transcription, we have the background sound detection, we are improving the video indexer, but how to assess it? And in this case, we had various colors of accuracy, which was in general 5 categories. The general accuracy, so we measure the word error rate, which is substitution, something which is mixed in one text and in another, because we provided the differentiation between our text, our automated created text with the human transcripted text. The dilation, so we haven't provided it automatically, and the human has heard it. And insertion, so the model, the automate has recognized it, but there was not such words in the videos. So we provided it in 5 categories. General, so we measure everything known, interpunction, numbers, and special words, so like this person, locations, and so on. And currently, we are after the POC and providing the next steps in the project, so also improving this accuracy. After the POC, the general accuracy, so all of the words is at 97%. Noun is 94%, interpunction 97%, numbers 92%. And still, we have the most issue with the special words. So currently, it's 81%, but we're still improving both video indexer. We're also trying to use some combination with Whisper to provide also for special words more than 90% of accuracy. Okay, that's all from my side. Thank you very much for the attention. And if you have any question, feel free.